What is the area of yellow region, X? Label points A, B, C, D, and E. Let the length of the square BY and line C, D equals to G. It implies that angle AC, B equals 45 degrees, which equals angle BA, C that is equals to angle DCE. For triangle B, C, D. Area equals half the product of G and Y times sine 45 degrees, which equals 4. Cross-multiply and solve for G. We have that the product of G and Y times sine 45 degrees equals 8. Simplify and we have that G equals the product of 8 and the square root of 2, all divided by Y. We call it equation 1. Let line A, D equals Q. Area of triangle AD, B equals half the product of Q and Y times sine 45 degrees, which equals 2. Cross-multiply and solve for 2. It follows that Q times Y equals the product of 4 and the square root of 2, all divided by Y. We call it equation 2. By Pythagoras' theorem, the square of line A, C equals 2 times the square of Y. Take the square root of the equation and we have that. It implies that line A, C equals Y times the square root of 2. But line A, C equals the sum of Q and G. Substitute values. It means that the sum of the product of 8 and the square root of 2, all divided by Y, and the product of 4 and the square root of 2, all divided by Y equals Y times the square root of 2. Simplify and we have that 12 times the square root of 2 divided by Y equals Y times the square root of 2. Cross-multiply and we have that 12 times the square root of 2 equals to the square of Y times the square root of 2. Take the square root of the equation. It signify that Y equals 2 times the square root of 3. After simplification, substitute value in equation 1 and simplify to have that G equals the product of 4 and the square root of 6, all divided by 3. Consider triangle B, C, D and use cosine rule. We have that the square of line B, D equals the sum of the square of Y and G minus the product of 2 and Y times G times cosine 45 degrees. Substitute values. Simplify to have that the square of line B, D equals 20 divided by 3 as shown on the screen. Take the square root of the equation. We have obtained that line B, D equals the square root of 20 divided by 3, which equals the product of 2 and the square root of 5 divided by 3. Let angle be D, C equals beta. Use sine rule. Y divided by sine beta equals line B, D divided by sine 45 degrees. Cross multiply and solve for sine beta. It implies that sine beta equals y times sine 45 degrees. All divided by line B, D, which equals to 2 times 3. All divided by the square root of 40. We call it equation 3. Thus, angle CD, E equals 90 degrees minus beta. It follows that angle CED equals the sum of beta and 45 degrees, after substitution and simplification of values. Since line C, D equals G, which equals the product of 4 and the square root of 6. All divided by 3. From triangle CED. Use sine rule. G divided by the sum of beta and 45 degrees equals to line C, E divided by sine 90 degrees minus beta. Substitute values. We obtained equation 4 as shown on the screen. By trigonometric identity. Sine of the sum of beta and 45 degrees equals the sum of sine beta and cosine beta. All divided by the square root of 2. Also, cosine beta equals 1 divided by the square root of 10. After substitution and simplification of value, using trigonometric identity. Now let's substitute our values obtained in sine of the sum of beta and 45 degrees. This gives us 4 divided by the square root of 20, which simplified to 2 divided by the square root of 5. Again, sine 90 degrees minus beta equals cosine beta as shown. Substitute value for cos beta and we have that sine 90 degrees minus beta equals 1 divided by the square root of 10. Then, substitute in all the values we obtained in equation 4. Hence, the ratio of 4 times the square root of 6 divided by 3 to 2 divided by the square root of 5 equals to line C. E divided by 1 divided by the square root of 10. Cross-multiply and solve for line C, E. We obtained a numerical equation for line C, E as shown on the screen. Simplify it and we have that line C, E equals the product of 2 and the square root of 3. All divided by 3. Or 2 divided by the square root of 3. What is the blue area? Label points A, B, C, D, E, F, G, and H. Join line B, G. Hence, the area of the inscribed red square A, B, H, G equals the sum of 1 and 3, which equals 4 square centimeters. Let the area of triangle B, H, G be equals to A1 and the area of triangle B, E, G be equals to A2. Let us first find the area of polygon EGH, which equals the sum of A1 and A2, where A1 equals half the area of ABHG, which equals 2 square centimeters. Let the side length of the red square ABHG be equals to x. It implies that its area 4 equals the square of x. Take the square root of the equation. X equals the square root of 4, which equals 2 centimeters. Consider triangle AFB. Area equals half the product of line AF and line AB, which equals 1 centimeter. After substitution and simplification of values, cross-multiply and we have that line AF equals 1 centimeter. By Pythagoras' theorem, the square of line B, F equals the sum of the square of line AF and the square of line AB. Substitute values. It follows that the square of line B, F equals the sum of the square of 2 and the square of 1, which equals to 5. Take the square root of the equation. Line B, F equals the square root of 5 in centimeters. It implies that line G, F equals line A, G minus line A, F, which equals to 1 centimeter. After simplification of values, let angle B, F, A equals theta. It follows that angle G, F, E equals theta. Consider similar triangles A, F, B and G, F, E. Line G, F divided by line E, G equals line B, F divided by line B, A. Substitute values. Hence, 1 divided by line E, G equals the square root of 5 divided by 2. Cross-multiply and we have that line EG equals 2 divided by the square root of 5, or the product of 2 and the square root of 5. All divided by 5 in centimeters. By Pythagoras' theorem, the square of line B, G equals the product of 2 and the square of line B, H. This implies that the square of line B, G equals 2 times the square of 2. Take the square root of the equation. We have that BG equals the square root of 2 times the square of 2, which equals the product of 2 and the square root of 2 in centimeters. It signifies that from triangle B, EG, using Pythagoras' theorem, the square of line B, E equals the square of line B, G minus the square of line EG. Substitute values and we have that the square of line B, E equals 8 minus 4 divided by 5, which equals 36 divided by 5. Take the square root of the equation. Line B, E equals the product of 6 and the square root of 5 divided by 5 in centimeters. Hence, area of triangle B, EG. That is, A2 equals half the product of line EG and line B, E, which equals to 6 divided by 5 in square centimeters. After substitution and simplification of values. Since line B, E is the side length of the larger blue-white square, let its area be equals to A3. It implies that A3 equals the square of B, E, which equals 36 divided by 5 square centimeters. Hence, the area of blue region of the larger blue-white square equals A3 minus the sum of A1 and A2, which equals 36 divided by 5 minus 16 divided by 5. The result equals 4 square centimeters. Therefore, the blue area equals 4 square centimeters.
What is the area of the square? Label B, C, G, D, and E. Line B, G equals diameter of the circle, which equals to 10 units. This implies that the radius, R, of the circle equals 5 units. B, O equals G, O, which equals 5 units, the size of the radius of the circle. Let the length of the square be x. Joint J, O equals R and K, O equals x minus 5. Line K, O is a bisector of line BC. It implies that BK equals C, K, which equals half of x. Consider triangle BOK. Using Pythagoras theorem, the square of 5 equals the sum of the square of x minus 5 and the square of half of x. Expand brackets to obtain a new equation as shown on the screen. Multiply the equation by 4 to clear fraction. It implies that 0 equals 4 times the square of x minus 40 times x plus the square of x. Combine like terms and factorize. We have the product of 5 and x, and the x minus 8 equals 0. Thus, 5 times x equals 0, or x minus 8 equals 0. Thus, x equals 0, or x equals 8. X is not equals to 0, hence, x equals to 8. But x equals the side length of the square. Therefore, the required area of the given square is the square of x, that is the square of 8, which equals to 64 square units.
Find the value of the yellow area. Label points B, C, G, D, and E. Join line B, D, and line B, C respectively. Locate the center O of the circle. It implies that line B, O equals line D, O which equals R, the radius of the circle. Let angle D equals alpha. By considering the properties of similar triangles, triangle EOD is congruent to triangle BCD. This implies that line C, D divided by line B, D which equals 9 divided by 2 times R, that is equals to cosine alpha. Also, line D, O divided by line D, E equals R divided by 5 which equals cosine alpha. Equate the two equations that are each equals to cosine alpha. We have that 9 divided by 2 times R equals R divided by 5.
Cross multiply and we have that 2 times the square of R equals 9 times 5 which equals to 45. Divide the equation by 2 and we have that the square of R equals half of 45. We call it equation 1. Since line DG equals to line BG, it is because of the side length of a square are equal. Use Pythagoras theorem. We have that the square of line B, D equals the square of the product of 2 and R which equals to 2 times the square of line D, G. Divide the equation by 2. Since the yellow area equals the square of line D, G which equals 2 times the square of R. Substitute equation 1 for the square of R.
It implies that the square of line D, G equals 2 times the square of R which equals 45 square units, after simplification of values. Therefore, the yellow area equals 45 square units.